Dear friends, today we learn about Hybridoma technology. What is Hybridoma technology? Hybridoma technology is the one of the oldest methods used for most popularly for developing monoclonal antibodies. Hybridoma technology is one of the oldest methods used for developing monoclonal antibodies. Monoclonal antibodies develop hybrid cell lines called hybridomas by the fusion of specific antibody producing lymphocyte B cells with myeloma cells, which has the capacity to grow in tissue culture. It is a method producing large number of identical antibodies called monoclonal antibodies. Hybridoma technology is one of the oldest methods and also the most popular for generating monoclonal antibodies. It is producing hybrid cell lines called hybridomas by the fusion of specific antibody producing lymphocyte B cells with a myeloma cell which has the capacity to grow in tissue culture. It is a method of producing large number of identical antibodies called monoclonal antibodies. Hybridoma technology was discovered in 1975 by two scientists, George Schuyler and Cesar Milestone. They were awarded Nobel Prize in 1984. The term hybridoma was coined by Leonard Herzberg in 1975. Then production of monoclonal antibodies. There have 5 techniques. First, that is immunization of mouse. Second, isolation of beta cells. Third, isolation of myeloma cells. And fourth, somatic cell fusion of myeloma cells and beta cells. And fifth, selection of hat medium. So this is the stepwise production of monoclonal antibodies. First, that is immunization of mouse. Second, isolation of beta cells from spleen. Isolation of myeloma cells. And fourth, somatic cell fusion of myeloma cells and beta cells. Selection of hat medium. So first step, that is immunization of mouse. In that 2 to 4 week old mice is immunized with specific antigen injection against which monoclonal antibodies have been produced. First step, in that 2 to 4 weeks old mice is immunized with specific antigen injection against which monoclonal antibodies is produced. Second, isolation of beta cells from spleen. After 72 hours of immunization, spleen is collected from the mouse and then beta cells are isolated from the spleen of an immunized mouse. Third, isolation of myeloma cells. Myeloma cells are isolated from bone marrow. Myeloma cells are isolated from bone marrow. Myeloma cells produce tumors and they cannot synthesize antibodies due to the lack of HGPRT gene. So technique first, immunization of mouse. 2 to 4 week old mice is immunized with specific antigen injected against which monoclonal antibodies have to be produced. Second, isolation of beta cells from spleen. After 72 hours of immunization, spleen is collected from the mouse and then beta cells are isolated from the spleen of an immunized mouse. Third one, isolation of myeloma cells. Myeloma cells are isolated from bone marrow. Myeloma cells produce tumors and they cannot be synthesized antibodies due to the lack of HGPRT gene. Antigen, spleen cell, myeloma cells, HGPRT fused together. Monoclonal antibody will be developed by fusion of myeloma cells and beta cells. Then first, culture media hat medium. Second, test each supernatant for antibodies. Third, clone each positive culture. The test each supernatant for antibodies. 4 step and 5 expand positive clones. Propagate in vitro, harvest monoclonal antibodies in vivo. So this is the stepwise production of monoclonal antibodies. First, immunization of mouse. Then fusion of myeloma cells with beta cells. Then test each supernatant for antibodies. Clone each positive culture. Fourth, test each supernatant for antibodies and expand positive clones. Propagate in vitro and in vivo. Test, harvest monoclonal antibodies. Hypoxanthine guanine phosphoribosyl transferase, which is required for synthesis of enzyme HGPRT. Somatic cell fusion of myeloma cells and beta cells. Myeloma cells and beta cells allowed to fuse with application of electrical field, i.e. electrofusion. Fusion for producing hybridomas is induced by using polyethylene glycol (PEG). Selection of hat medium. Hybrid cell of hybridomas are developed in selective hat medium. Hat means hypoxanthine aminopterin thymidine. Hypoxanthine aminopterin thymidine. Nucleotide synthesis is important for cell survival. Hat medium contain drug aminopterin, which will inhibit the cellular synthesis of purine and pyrimidine from the simple sugar. Myeloma cells are unable to grow. Beta cells are able to survive but cannot live for extended period on of myeloma cells and beta cells using PEG of cell lines. Hybrid cell HGPRT enzyme beta cells as well as they can be capability to multiply repeatedly as the myeloma cells. So only hybridomas can live in the hat medium. Hybridoma cells will then secrete large quantity of antibodies and screening of suitable cell line in vitro and in vivo multiplication harvesting of monoclonal antibody. Then purification of antibodies. Monoclonal antibodies we need to purified before they used for variety of purposes. Purity is needed because to avoid the toxicity or avoid the unnecessary effect, adverse effect. So this antibodies, monoclonal antibodies will purified using ion exchange chromatography and antigen affinity chromatography. Applications of hybridoma technology. Then therapeutic application. Monoclonal antibodies have wide application in the therapeutic either directly or as a targeting agent. This application include treatment of autoimmune disease. Auto means self immunity system developed diseases or disorders, autoimmune disorders like rheumatoid arthritis, joint disorders, treatment of AIDS, treatment of cancer, immunosuppression of organ transplantation. Then diagnostic applications. Therapeutic application, that is treatment of autoimmune diseases, treatment of AIDS, treatment of cancer, immunosuppression of organ transplantations. And then diagnostic application, biochemical analysis. In diagnostic imaging in the detection of various severe diseases, in protein purification, miscellaneous. Monoclonal antibodies are used in the identification of ABO blood group. Then the application of hybridoma technology to studies of monoclonal antibodies is relatively new research development. Biomedical research, great commercial and medical value. Diagnosis including ELISA test for detection of viruses and imaging, immunopurification therapy. ELISA means enzyme liquid immunosorbent assay. So today's section we learn about what is hybridoma technology. Hybridoma technology is one of the oldest methods used for development of monoclonal antibodies. How to develop monoclonal antibodies? Producing hybrid cell lines called hybridomas by the fusion of specific antibody producing lymphocyte B cells with the myeloma cells, which has the capacity to grow in tissue culture. Then hybridoma technology discovered in 1975 by two scientists. Stepwise production, that is immunization of mouse, isolation of beta cells, isolation of myeloma cells, somatic cell fusion, myeloma cells and beta cells, selection of hat medium, immunization of mouse. In that 2 to 4 week old mice is immunized with specific antigen injection against which monoclonal antibodies have been produced. Second, isolation of beta cells from spleen. After 72 hours of immunization, spleen is collected from the mouse and then beta cells are isolated from spleen of an immunized mouse. Isolation of myeloma cells. Myeloma cells are isolated from bone marrow. Myeloma cells produce tumors and they cannot be synthesized antibodies due to the lack of HGPRT. This is the stepwise production of monoclonal antibodies. Purification of antibodies, that is ion exchange chromatography and antigen affinity chromatography. Application: therapeutic application. Monoclonal antibodies have wide applications in autoimmune diseases treatment, treatment of AIDS, treatment of cancer, immunosuppressions, organ transplantations. Diagnostic applications: biochemical analysis, in diagnostic imaging, in the detection of various severe diseases, in protein purification. Miscellaneous: monoclonal antibodies are used for the identification of ABO blood group. In the relative new research developments, also use essential tool for biomedical research. Thank you. Keep reading, keep growing. Thank you.